All right, sorry about that. My headset cut off as soon as I started. All right, so I've got three shapes here. We're going to reflect them over each of the given rules in purple, and this will help you guys with some practice as well as just get you more familiarized with it. So y equals x. So I'm going to go ahead and let's see, what was I using last color for that? In green, and go ahead and draw my y equals x line. Remember, think of slope-intercept form. Think back to when slope was positive 1. That means that it's up 1 over 1. So we've got a positive slope, up 1 over 1. So there's my line that I'm going through. I'm going to reflect over. So I'm going to go over into the fourth quadrant. So my image coordinate values, my pre-image, right? Oops, let me keep that just that way. For A, B, C, and D. For A, it's 1, 2, 3, 4, 1, 2, 3, 4, so it's 4, 4, or negative 4, positive 4. For B, it's over 2, up 4. For C, it's over 2, up 1. And then for D, it's 1, 2, 3, 4, over 4, up 1. So a typical rectangle, nothing crazy there. So if we applied this rule, right, and the rule for this guy was, if we're reflecting over y equals x, if we go back to here, then our rule is going to be xy becomes yx. They flip location, right? That's it. They don't change any signs. You just flip them around, okay? So that is our rule for that one, okay? All right, so if we go ahead and apply that rule, my image should be that A prime is going to be 4, negative 4. B prime will be 4, negative 2. C prime will be 1, negative 2. And D prime will be 1, negative 4. Okay, so nothing too crazy. All right, we then apply that. So we're going to go over here, 1, 2, 3, 4, 1, 2, 3, 4. So right here is A prime. B is then over 4, 1, 2, 3, 4, down 2, 1, 2. Okay, there's B prime. C is over 1, down 2. Then over 1, down 4 is D prime. So notice that when we reflect it, it's not like a direct, like inverted rectangle, like with 180 degrees. Again, that's the discount. This is the actual real deal of reflection. When we have the real deal, the orientation does some pretty wonky stuff. Conceptually, it might bother your brain, but I promise over time you'll get a bit more comfortable with it through practice. So that's what we should end up there. All right, let's do the next one. So the next one has us reflecting over y equals positive 1. This is one of those situations where, if you remember back in the description, which I have right here, and I added this after the fact of the other video, sorry, but this was from class. The other vertical and horizontal components count the distance from the point to the line mirror to the other side. So all we're going to do is we're first going to get that line graphed, which if y equals a positive 1, that means we're going to move up 1, okay, because there's no slope. There's no, it's just an intercept value. So he's right there. Okay, that's where y equals positive 1. Okay. I'm going to underline those components in green since I'm drawing them in green. There we go. Okay, so we're reflecting over that. So all you're literally going to do is you're going to count the distance. So A is 1, 2 off, so it's 1, 2 up here. C is 1, 2, 3, 4 off, so we're going to go back up to here, go 1, 2, 3, 4. B is 1, 2, 3, 4, 5 off, so we're going to go 1, 2, 3, 4, 5, and he's right here. Now, when you plot this, you are going to count from the original axes, not from your new reflection line. This is technically the new axis, but we call it that because we're lazy mathematicians. Okay, we're moving up the axis and reflecting over y plus 1 instead of just y equals 0, which is effectively the y-axis. So same procedure, more or less, but the difference here is that we're going to be shifting up. This is where you can also write some custom rules for these eventually, right? So let's go ahead and do that now. So we'll go ahead and connect our points real quick. And then we're going to list out our values. Okay, so here is A prime, C prime, and B prime. So for our pre-image, A prime, B prime, C prime, and D prime, okay. Oh, and I just did it in the wrong spot. Oops. I messed up. A, B, C, and D. So A is 1, 2, 3, 4. It's 4, -1. B is going to be over 1 and down 1, 2, 3, 4. Yep, over 1, -4. And I don't need a D, actually. I wrote D by mistake. So C, I had a brain fart there. C is 1, 2, 3, 4. 1, 2, 3. So that is over 4, down 3. Okay? So then our image, sorry, I bumped the page of the microphone, is going to be A prime, B prime, and C prime. For A, we're going to go, now remember, don't count from the green line, count from the black one. 1, 2, 3, 4. 1, 2, 3. So we're going to go over 4, up 3. 1, 2, 3, 4. 1, 2, 3, 4, 5. Over 4, up 5. And then over 1, 1, 2, 3, 4, 5, 6. So over 1, up 6. Now, notice something interesting. The y's, the x's didn't change, much like where y equals x, or sorry, when we deal with the y-axis, or sorry, the x-axis or the y-axis, they stay in the same position, just the signs change. Well, here, they didn't change at all, so, or at least the back numbers did, and they changed negative. So we could hypothetically write what I like to refer to as a custom rule. So what would be the custom rule? And I am going to change something up here. I'm going to cross that out and move it right up here. So it's up top. So x, y to y, x. So just a small little change. I do apologize. All right, so I need to get rid of that guy as well. There we go. So if we make that change, so here's how you would write the rule for this. So we're going to use x, y, obviously, and the x's don't change, so you can just say x. They stayed the same. The only thing that changed was the y. They all went up a certain value. They all went a value up by 2, and they also changed the sign. So what you can do is you can write this a couple different ways, but I prefer to write like this. Negative times y minus 2. Because you have to get the value up and then switch the signs around. You could have also done plus the value from there. So you could have done it different ways, but that's just one algebraic way to do it. And that's how you write your own rules. And that'll work for any of those points. You plug in -1, you get -3, flip it, 3, done. You plug in -4, you get 6, flip it, you get 6. So -3 minus 2 is going to give me -5. Times -1 gives me 5. So it works for all of these, and that's how you write a custom rule. Okay? So let's go and move on to the last one, which is a little tricky. Don't freak out. It's a trapezoid. It's not the end of the world. Okay. So we're going to be reflecting this over y equals negative x. Which means we have a negative slope going down, which means it's going to probably end up in what? I'll give you a second to respond, and then I'll tell you the right answer. That is the first quadrant. If you said first quadrant, you're right. If not, you'll see why here in a second. So our pre-image and our image, A, B, C, and D. A is at -1, -1. B is at 1, 2, 1, 2, -2, -2. C is 1, 2, 3, 1, 2, -3, -2. And D is at -4, -1. Okay. So there we go. So my A prime, B prime, C prime, and D prime values. All right, let's figure these guys out. So if we go ahead and reflect over the y equals negative x axis, or y equals negative x, meaning our slope line there, sorry, not axes, but our line, that means that we're going to get xy becomes negative y, negative x. Okay, so we negate and flip. So if we flip those around, we're going to get 1, 1, we're going to get 2, 2, we're going to get 2, 3, and we're going to get 1, 4. Okay? Let's plot it. So, all right, just doing a little bit of repair work there. Okay, so let's go ahead. We're going to go over 1, up 1. We're going to go over 2, up 2. We're going to go over 2, up 3. We're going to go over 1, up 4. And there is my new trapezoid. A, B, B prime, A prime, C prime, and D prime. And voila, there he is. So hopefully those rotation examples, sorry, not rotation, wrong R, reflection examples helped you guys out. We'll go over definitely more of these in class, and your homework will also help you get extra practice. So good luck.